So in this lesson, we're going to look at Pythagoras' theorem for the first time, and we're going to investigate how we use it to find the length of the hypotenuse of a right-angled triangle. So first of all, we need to have a think about what Pythagoras' theorem actually is. Now, basically, in a geometric sense, what it's saying is that if we have a right-angled triangle and I square the two shorter sides, so that's that square and that square there. Well, when I add those together, what happens is I get the area of this big square, which is of course c squared. So that is Pythagoras' theorem in a geometric sense. Now, what you're going to be used to using is this: a squared plus b squared equals c squared. And we need to be a bit more formal now about what these things mean. The c, the diagonal, is referred to as the hypotenuse, and that's what we're going to be looking at trying to find throughout this 5-minute presentation. This diagonal side, and you can recognize it because it is the furthest one away from the right angle. It doesn't touch the right angle, and A and B both do. A and B are at 90 degrees to each other, they're perpendicular to each other, and so that's how we can identify between the hypotenuse and the other two sides. So let's look at some examples now. So this is the first one. We're going to use that Pythagoras' theorem to work out the length of the diagonal. Now I'll call what we're trying to find x, and so let's get started. So Pythagoras' theorem says that if I have the two smaller sides, the a and the b, and I square them, so 7 squared plus 8 squared, well, what that's going to give me is x squared. So if we work this out, well, 7 squared is 49, and 8 squared is 64, and if I add those together, I get 113. So that side, that hypotenuse squared, is 113. So now all I need to do is square root that on my calculator, and that comes up as, rounded to one decimal place, 10.6. So there's the length of the hypotenuse, 10.6. Now, let's see if we can go through that again. Here's the second example. So my two smaller sides, A and B, are 1 and 5. So I know that if I call that x again, that 1 squared plus 5 squared is going to be x squared. So 1 squared is 1, 5 squared is 25, so that gives me 26 when I add them together. So 26 is going to be x squared. Now all I need to do is square root 26 to get our final answer. So the square root of 26 on your calculator, rounded to one decimal place, is 5.1. So there is our value of x. Now don't forget the units. Let's just go back. The first one was in centimeters, and the second one was in meters. So those are our two answers. So let's have a look at another type of question now. We have to, in this case, verify that Pythagoras' theorem is true for this particular triangle. So that, if it's true, we're going to have that 9 squared plus 40 squared, those are the sides A and B, are going to be equal to 41 squared. So we better work out what 9 squared plus 40 squared is. Well, 9 squared is 81. 40 squared is 1,600. So if I add them together, of course, I'm going to get 1,681. All we need to do now is check what is 41 squared. I do hope it is 1,681. So 41 squared, and you can do it on your calculator. Yep, absolutely, it is 1,681. So Pythagoras' theorem holds, and this tells us that this is indeed a right-angled triangle. In this final example, we're going to try and put some context into the questions. So in this case, we're asked to find out what the diagonal is. And the diagonal of a rectangle means the distance between two opposing corners, like that. That's the diagonal. So as you can see, one side of this forms a right-angled triangle. We've got that one of the sides is 8, so we'll look 8 squared, added to the other side, which is 16, so plus 16 squared. that is going to be the diagonal squared. So let's use some algebra again and call that x. That's going to be equal to x squared. Right, so if we add this up, 8 squared plus 16 squared, let's skip a stage here, and then we'll square root that. So let's try and do it on our calculator in one go. The square root of 8 squared plus 16 squared. If we type that in and press equals, we're going to jump straight to our final answer. Now, you should always show your workings, but we can do that on a calculator in one go. Now, that is going to be 17.9 centimetres if we round to one decimal place, and we are finished. That's all you need to do to access the first set of questions on this unit. Good luck.